In the previous examples of what we've done for nomenclature, we focus on metal, non-metal compounds, and we'll come back to those in a little bit, but we also want to talk about what happens when you have a non-metal with another non-metal. The most important thing to remember, and you've probably heard me say this before, is that all previous nomenclature stays the same, which means what we're doing today does not apply to things that we did in the last times, not the last times, I shouldn't say it that way, but in the last sessions. And with what we've done so far is that we've done what I sometimes call the simple metals, sometimes called the always metals, where they only have one possible charge. That was in our first session. And we've done the other metals last time, which was the type where we use Roman numerals. And that can have more than one charge on the metal, and the Roman numeral tells me what the charge on the metal is. Okay, we also know that nonmetals can form compounds with nonmetals. We also know what type of bond those are going to take, at least we probably do by this point, but they're not going to form charges, because if two nonmetals both want to do negative charges, you can't have total negative charge being total positive charge, because there's no positive charge. So they don't do charges. Okay, so if I have this, and this is not going to be what I use, but keep in mind what we said about group 17 metals was they always become -1 with metals. We don't have with metals. So what happens? Well, we're not going to talk about the bonding going on right now. We're going to talk about the nomenclature. But the number one thing is that there is no charges. So all my previous nomenclature has been about how to handle charges. So I don't have charges. So in this time, what we're going to do is we're going to just make it a whole lot simpler. Now, I need to warn you, this nomenclature is going to be really easy. So easy, you're going to want to use it for everything. It doesn't apply to everything. It doesn't even apply, really, to all compounds that are involved nonmetals and nonmetals. But that's another story along the riverbank. So, we use a prefix. Whoops, hang on, which direction was that going? Did that. Here are the prefixes. The first 5, and I'll just let you pause and write them down, and then the next 5. Yes, there are more prefixes, we're not going to use them. So we're just dealing with ones that go up to the first 10. That's enough. Okay, what it comes down to is the formula is the name. Now, if you've seen this kind of nomenclature before, and honestly you probably have, you probably maybe knew that already. But if you have compound diarsenic trisulfide, what that means is there's 2 arsenics and 3 sulfides. That's it. So I would write it down with the little numbers. 2 arsenics, 3 sulfurs. That's the name and the formula. Something that's different from the last couple sessions is something that's sort of a temptation to get into, because you've kind of built that sense of automatic into it, but we don't do the crossover. We don't do the crossover, and we don't do the reduce. And that's one key difference, important key difference, which I guess is the same thing, with this kind of nomenclature. We don't cross over, and we don't reduce. There are a couple of tweaks. Now, when I say tweaks, I mean these are things that they're really not necessarily a rule, but it's what everybody does. So, if there's only one type, only one of the first element, we can assume that there's one of them and not say so. So you're probably familiar with CO2 being carbon dioxide. Notice we don't say 1 carbon. We say how many oxygens there are, dioxide, but we don't say monocarbon. Although honestly, if you did say monocarbon, you're not wrong. It's just nobody ever uses that, so they don't know what you're talking about. Bromine monochloride. Well, I have 1 of each, but if I have 1 bromine, the first element, I don't have to say so. I always have to say how many I have of the second element. And sometimes we'll get a little bit lazy on, lazy is probably the wrong word. We get a little bit lazy on the prefixes. Not all of the ones that you think we should get lazy on, but we don't say monooxide because that sounds like a lot of stuff to say. We just say monoxide. And if we had, what have we got there? 4 tetraoxide. Tetraoxide is not wrong. It just sounds hard to say, tetraoxide. So we just tetroxide. Again, having the full prefix there would not be incorrect. It would just sound kind of funny. However, a lot of the nomenclature we do is written, so final thoughts, and you know it's coming because I've already said before, is all the previous nomenclature stays the same, but more importantly this time is that this does not work for metal, non-metal compounds. Once in a while you'll see it being used, but it's not correct, it's not proper. It's more sloppy than we'll allow ourselves to be. And I mentioned at the beginning of the video that there are some compounds that are non-metal that don't use this system. We'll get into a couple of those, but we're really not going to focus on that at all. I want you to be aware of it, but that's about it. Anyhow, hope this helped.